Hello, students. Today we're going to be taking a look at our Chapter 11 review, Form 2A odd select questions. So let's take a look. Now, Form 2A is the free response portion. You should have hopefully have completed the multiple choice portion over the past couple days here. So let's take a look. So we're going to jump in. Question 1 says name two chords of circle Q. So if you look at the picture, you've got circle Q. Now remember, a chord is a segment whose endpoints are on the circle. So for our purposes here, clearly US is one answer, and you can flip the letters to be SU. And yes, it's also the diameter. A chord could go through the center. It doesn't have to, though. For example, chord VT, or if you flip it, TV. Now, segment RQ is not a chord. It is called a radius, though, specifically, as is QS and QU, just to name a couple of different ideas to think about there. Let's move on. Number 4. Refer to the figure shown at the right. Name 3 minor arcs that have E as one endpoint. Find the measure of each arc. So what I typically like to do with these questions is I like to kind of frame where if you know the central angle, you also know the respective arc that is created by it. So that arc BC, which is a minor arc, is 36. This arc ED is 42. And you can kind of fill in the rest. Now, they don't say it in the problem, but BE I will assume as a diameter, as will I assume AD to be a diameter. So that implies that you can subtract to find this central angle CPD, which I'll do quickly by subtracting the sum of, after we see here, of course, in parentheses, noting 180 minus parentheses 36 plus 42. So that yields 102. So that angle is 102. Therefore, this arc is 102. Because they're asking for arcs whose endpoint is at E, minor arcs that is, well, we already have one, right? I'm going to be filling in the rest of the arcs and angles in a moment, but we actually know, of course, that arc ED, minor arc ED, is equal to 42 degrees. And we can actually do some quick analysis where if we wanted to find arc EDC, we could do that by adding 42 and 102. So arc E. Now I'm going to leave out D because we usually don't use 3 letters with minor arcs, of course. So EC is enough. So including D is not necessary. So what? 142, because 42 plus 102. Correction, 144. All right, easy enough. Now it does want 3 minor arcs, so we could include, for example, this arc. All right, arc EA. Okay, now it appears that we also happen to have, because I said BE is a diameter, 180 degrees, noting arc EAB there. I'm going to use the vertical angle idea to highlight these two angles as congruent because they're vertical. Therefore, this is also 42. This is also 42. So we can again do some quick math, but what? Subtract 180 minus 42. That should be 138. So we've got that for this central angle, and therefore this respective arc is also. We'll finalize that with listing of minor arcs, and there you have it. Arc EA then is, like I said, 138. Okay, let's move on. Number 8, so the next little section of problems. Use the figure at the right. Here's your circle, circle C. Now there's some aspects that I typically like to mark up when I'm doing problems of this nature. We know we've got radii CE and CG because they're both radii, of course, of the circle. They're congruent. I'm not going to mark CF congruent to those two, simply because I've got a lot happening here where you've got CF as perpendicular to GE. There's going to be some bisecting happening as well, which I will mark up here and here. There's a theorem we learned that that's the case because it's not only a perpendicular segment to this chord GE, it's also going to bisect it. Okay, so we may or may not use that on this particular part, but I want to mark things up just in advance for the sake of, who knows, maybe needing it later. Okay, so here's the question. If segment ED is congruent to EG, so I'm going to mark it up, or better yet, this will be a little bit more difficult. I've seen where in the past it can be marked up, but I'm going to use this notation instead. This segment is congruent to that segment. So those two chords. Now, why did I do that? First, I didn't want to confuse the issue because segment GE is obviously more than one, has more than one kind of part to it. So I'm just going to note that, but also, well, as it turns out, because those two segments are congruent, yes, they're also called chords, I can mark this arc congruent to that arc, which again isn't as easy to represent with multiple kind of arcs noted, particularly with arc G, E, including point F there. But it might be worthwhile here separately noting that arc E is congruent to arc E. Because again, the chords are congruent, so should those respective arcs that are created by those. Okay, so arc E, D, G. I want to also maybe mark one last little bit here, maybe have you guys note this as congruent to itself, which is strange, right? Arc DG is congruent to itself, but we've seen that before in various applications, if you recall the reflexive property. So let's pair that up with kind of our current statement, such that DG is congruent to itself, arc DG. Okay. So think about this for a moment. If you were to interpret what we already say that EDG is a combination of the arc marked with 3 markings and the arc marked with 4 markings. That's what it's comprised of. It should work out where if we go in the other direction, it's also true. So 3 markings in the other direction, different color here. So the 3 marking segment, so EG pairs up where if you add it to the 4 marking segment, DG, you got your results. That particular arc that's congruent to E, D, G in red is the green one. So arc E, G, E. Okay. That's the major arc that is congruent to E, D, G. As far as the lettering goes, I wrote E, G, I wrote E, excuse me, it should be D, pardon. But as far as the lettering goes, this is fine, although I could theoretically use letter F in my answer, but EGD is perfectly good. Let's move on to the next page. All right, I've already done number 13 in a previous video, so I'd like to possibly take a look at, let's see here, we've got a pretty interesting question on number 15 there, and or number 16, so maybe we'll take a look at both. The figure at the right is formed by placing a semicircle on top of a rectangle. To the nearest foot, what is the distance around the outer edge of the figure? Okay, so at the bottom of the rectangle, you see 6. On the side of the rectangle, you see 10. So let's say width of 6 and length of 10. Turns out, because we have 6 feet there at the bottom, we can split it up, not surprisingly, into 3. If we were to put a midpoint there at the bottom. So at the midpoint, we're seeing here half of which is 3, the other half is 3, of course. So that helps us with, well, not surprisingly, then the semicircle. Again, because they want the distance around the outer edge of the figure, we're going to need to use circumference, and we're also going to need to use partly circumference, and we're going to need to use what we know as far as the rectangle, or at least what's highlighted. So I can also maybe mark up this side as 10 feet circumference-wise. Again, this is technically, think about it, only half of the circumference, which we remember hopefully is C equals 2 pi r. Now I did write it as kind of my radius represented, but I could in theory also represent it as pi times diameter. Either way, if you do it that way, then you would in fact use 6. Okay. So we're going to do this. Oh, and by the way, that's technically, generally speaking, how this is going to play out. But let's maybe specifically note, because I only want half the circumference, you'll do half of 2 pi r, or half of pi times. Okay, so that's going to be something to think about as we continue here. So as far as adding up all the values, we know we've got a side of 10, upper side of 10, a side of 6, and then the circumference cut in half. Let's maybe use this equation because we kind of geared up already for using maybe the radius appropriately. So I'll use in this equation half 2 pi r. These are going to cancel. So you're really just doing pi times r. So 1/2 the circumference is equal to pi times the radius. Okay, and that of course we said was 3. So we're looking at 3 pi. And that also should be in feet. That's all said and done. Okay, so if you do the math, of course, 10 plus 10 plus 6, that's 26. So we got 26 plus 3 pi, which, as a decimal, use the pi button, please. The better answer, 35.4. And to the nearest foot, we'll just say 35. We'll call that the quote-unquote perimeter around this particular figure. I'll finish up with number 16. About how many revolutions must a 4-foot diameter wheel make in order to travel 200 yards? Now, if it isn't already obvious, and I guess in a sense number 15 helped us with this particular question, because take a circle whose diameter is 4, which also implies that the radius is 2. We do use radius in most applications, but we could also use diameter if we want. Again, the circumference of this particular circle, which, by the way, if we start at this point, and imagine, if you will, maybe cutting the circle such that you have an unraveled version of it. This circle cut at, let's say, the point that I've noted in blue, and then unraveled would look something like this, or at least the circle would look something like this, unraveled. Circumference is essentially the perimeter around the circle. And because we know the formula for circumference, we've got 2 times pi times 2, which is the radius, so that's simply 4 pi. This segment is 4 pi. Now it wants to know how many revolutions. Well, that's just one revolution, 4 pi. Okay, I'll write 1 rev. We want it to travel 200 yards. Remember, we did put this in the context of feet. So we can either convert 4 pi feet to yards, or we can convert 200 yards to feet. Either way, I think, how about for the sake of quick argument, we take 200 yards and multiply it by 1 yard equals 3 feet. So that's the little fraction in the way we convert. The yards will cancel, and that then leads to the following: 600 feet. So we already have 4 pi feet, and if we want to get to 600 feet, we want to multiply that by a certain number, correct? So 4 pi feet times x revolutions, okay, will be equal to 600 feet. So we type this into our calculators. Let's see what we end up with. 600 divided by 4 pi. Now, in a previous video, I did show you that when you divide by a quantity of this nature, if you don't use parentheses, so here's the right answer first, 47.7. But if you don't use parentheses, look at the difference. It is significant. And that's the wrong answer, 471, certainly. Because this problem wanted the number of revolutions, we'll take our answer, 47.7, and we'll simply round that to 48. So that should be final answer, 48 revolutions.